open pit optimization, and a PhD in blasting mining engineering. I joined the University of Queensland um, in their research and development wing of the mining industry. And for 18 years, I was researching crushing and grinding of rock, that's comminution, blasting, a bit of mining geology, geostatistics, flotation, and a bit of leaching. I left the academic circuit after 18 years and joined the private sector to support feasibility studies. Did that for a year. Then I left the mining industry behind because I was collecting information to show that the mining industry was grading into a new era where things were difficult, but corporate leadership didn't quite understand why. I came to Europe to learn industrial recycling in the University of Liège in Belgium. And while I was there, my job was to attend meetings up in Brussels about the circular economy in the H2020 and Horizon Europe meetings, and where I found the circular economy and learned about, I saw some really strange things, and that's actually the source of where my current work is. I left Belgium and I came to Finland to join the Geological Survey for the mineral intelligence group that's operating. And now I'm an associate professor attached to circular economy solutions. I'm operating on 4 fronts. I'm implementing geometallurgy which is the handshake between geology and mineral processing. I am looking at developing the digitization of the pilot plant at Outokumpu to make it more modernize it. There's things like machine learning and instrumentation and what have you. I am looking at reinventing the circular economy, developing it into something more sustainable and suitable. And I'm also looking at mineral intelligence activities with regard to what society will need to meet the twin challenges of phasing out fossil fuels and resolving our resource scarcity issues, as in consumption of resources. Where this work came from is when I arrived in Europe in 2015. I would sit in these meetings and I would listen to the European Commission officials say this is what our plans were, and in Australia, in the Australian mining industry, the Europeans are sort of seen as very advanced, far more advanced than we are. They thought things through, and they're just doing better. But when I was sitting in these meetings, I was really surprised to see a lack of hard numbers in anything. What I was expecting after 10 years of discussion and such well-funded discussion was a feasibility study, at least at scoping scale, for industrial reform to phase out fossil fuels. I was expecting to see this sector will need this amount of power. We're going to have to come from these systems. This is how many stations we need. This is who will own them. This is who will run them. And this is the metrics of performance that they will be required to operate. And sector by sector, I was expecting right across Europe for them to at least thought that through, and then connect that to the circular economy discussions about how we handle our waste and what we could use that waste for. As it turns out, there was none of that. And we hadn't really sort of evolved past the this is a good idea phase, where people stand up and say, this is a great idea, this is what we should do. And the next phase after that is we actually start to look at the practicalities of that and get to the point where we actually do it. Because we never actually sort of done that, a lot of the plans that were being proposed were obviously flawed. Now, there's a number of reasons for that, I believe. In Europe, they don't engage in mining. The Europeans in general believe it's beneath them, right? And they're more advanced, they would say. And so what they actually do is they're buying finished manufactured products off the market, which are made in China. What manufacturing that does happen in Europe is made on components that are made in China. And the Chinese are actually sourcing raw materials from all over the world, and they control the smelting and refining of chemicals and metals, and manufacture in many cases as well. So for the last 7 or 8 years, I've actually engaged to actually sort of communicate what I was seeing, assess the green transition. Will it work? Like, what can we actually deliver on this? And so I found some issues, but I've also develop the next generation of workers. So if the green transition won't work, and we can go through why that is in a moment, what might we do on top of that, because human innovation is a thing. What could we do? We're not going back to fossil fuels. Fossil fuels are going. What could we do? And so, and this is the way the work is at the moment. And so I've now sort of developed a plan that might work. And that plan is now operating at 3 levels. One's the global level with the Club of Rome. I'm at the nation state level. I'm writing a series of reports of what a nation state, like, for example, Hawaii, the Hawaiian Islands in the Pacific, what would they have to do to phase out fossil fuels, and what are the various options that face them? And then I'm actually working with the Venus Project in Florida, in America, with regard to, well, if we were to actually sort of build an innovation city and resolve some of these issues that I'm seeing and actually apply a solution and resolve some of these big questions, what would that actually look like? And so that's where we're at the moment.
Sorry, thank you. But one thing I think it's important to get clear. Some of the people who were, throwing stones at me for inviting you, said he's a fossil fuel fan. So can
Sorry. Sorry.
No, so can you clarify? Because when I was listening to several of your talks, looking at your 1,000-page report, which is freely available for anyone, I didn't get the impression that you're pro fossil fuels at all. You were very, very clear. You just made it clear. Look at how much stuff we got to dig out of the ground, 20 times copper and all that, and it's just not feasible. So if you can clarify those points.
Okay, so I'll take it a step further. Before I wrote the 1,000-page report, I actually wrote a report on the oil industry, I've been studying concepts like energy in crushing and grinding for about 20 years. And our industry at all levels and our society at all levels is dependent on fossil fuels. That's where that came from. And I wrote an outlook report. If you go to my website and look, the oil from a critical raw materials perspective is a outlook report on the oil industry. And that is like a brutal look at the oil industry. And it shows that the oil industry is facing serious headwinds in delivery. We actually can't continue with that. So no, I'm not pro fossil fuels at all. What I have found is if you're in this space at all, it's very ideological, and people to be very, very aggressive in defending that ideology. And we're very tribal. You're either in one tribe or another.
Yeah.
I'm actually talking to all tribes, and I'm actually blazing a path to where there are no tribes. I'm out on a limb all on my own. So what I'm trying to say here is the fossil fuel system, apart from all the climate change issues associated with fossil fuels, you've also got the resource depletion issues. We are in the process of transforming society in ways that are so fundamental, and they're just not that well understood. So a lot of the people who really don't like my work, when you actually look at it, many of them are part of the financial sector who are hoping to make a lot of money in the green transition groups. They tend to be the groups that tend to throw rocks at me, but then a lot of this stuff's taken out of context. It really is. Yeah. And so what I would say on the climate change sector, I used to work in the coal industry in Australia about 30 years ago. And there was a group within the coal industry that was trying to assemble data to actually sort of meet the climate change activists and in debate. They actually invited me to join them, and I declined because I did not like the paradigm that they were operating to. Climate change is a real thing. Where my thinking is the most serious problem within climate change is actually species die-off, land degradation, ocean acidification. It's essentially all the waste plumes that are coming off human industrialization, and we should sort of get in there and fix that, right? And to get to fix the carbon issue, we plant lots of trees and rehabilitate land that's been sterilized by industrial agriculture. That's what we should be doing. But instead, we're flogging ourselves over a carbon tax. And it's not clear what they're going to do with that money. So what I'm saying is when I write my reports, I'm very careful to. Usually, what happens when someone writes a report in these topics, they either go to market price or they go to carbon emissions. My work's been structured in a way where someone can pick up my work and very quickly turn it into either one of those things. But I'm trying to keep the work in terms of physical raw materials needed, physical numbers of units on the ground. And because if you actually start sort of adding other things, it does tend to get complicated. So as a consequence of that, people might sort of say, "Oh, you're anti-climate change." Absolutely not. Get a grip. um, but we've got to actually sort of partition this up to the point where we can actually start doing something. And here we are.
But you mentioned a couple of things before we started. One about human innovation,
Hmm.
about coming up with technological breakthroughs
Hmm.
which reduce carbon,
Yep.
innovative ways of
Yeah.
building
Lots of them.
wind turbines from trees and things like that. So that's one thing. Won't that help? And the second thing, because of the war in Ukraine, Europe has become totally obsessed, and they've actually seen results of energy efficiency, resource efficiency. So won't those two things help us?
Well, it depends on what you mean by help. So, one thing I have learned in this is everywhere I presented my work 230 odd times now to various groups around the world, and about maybe a third of the time I'm talking to a government official in some form. And what is clear is I often hear the following words: "We are encouraged not to say anything negative." Right. So there's this censorship and this self-censorship not to say anything that might, for example, imply poor economic results or something that might cause criticism later. And so there's the point we're sort of we're at this thing where we're not allowed to sort of talk about anything challenging at all. And human innovation is a thing, but we've got to allow it to happen. Like I'm part of lots of research proposals. I'm working in a battery chemistry project, for example, and we are trying. I'm trying to sort of get proposals up and running, and but the proposals are also filtered. We'll only consider a lithium-ion chemistry
Mm,
proposal. Anything else, get rid of it. Right, and so we're in this sort of constant treadmill of, well, innovation is a thing, but we're not going to allow it to happen. And so innovation tends to happen outside the existing tribes.
yeah.
And the people in those tribes point blank refuse and will kill off any suggestion that those outside ideas exist. And that is how we've got to this point where I say something very basic using maths I learned when I was 8 years old. And people are shocked and they are so surprised and it's so jarring. And this is what, because collectively over the last 50, 60 years, we've sort of approached things this way. So there are human innovation things that we can do. Now, so I'm an engineer, I'm a scientist. Give me a problem, let's work it. What's going on? That's the science. What do we do about it? That's the engineering. Right. So one of the problems of wind turbines, for example, is their blades are made of composite
Yeah.
plastic, and there is no recycling solution for them, and they send them to Africa to be landfilled. And so if we go, for example, the full green transition energy mix, where wind and solar take up about 70 or 80% of that total energy mix, we're talking about millions of wind turbines where tens of thousands of turbines would have to actually come offline to be recycled at the end of their operating life. Right. So we've now got a waste plume that we traditionally landfill that's
Mm,
coming off that. Right. Solution. Make the blades out of something else.
okay.
Right. And so this is the idea, where there's a couple of companies around that are looking at like making blades out of, for example, some sort of biomass
Mhm.
product made from wood. Um, we may have to accept a working life that's not quite as long as the others, but you can actually do something with them when they're done. That that being said, the problems I've highlighted associated with wind and solar, and I get a lot of criticism for this, is wind and solar are highly intermittent in supply. Right. Now, our electrical technology, our electrical engineering requires clean, stable power. The electricity's got to come out of the wall, the same voltage, same current, and the same frequency within a very narrow bandwidth. And if we get any power spikes at all, any variations, we get what's called a brownout, that cooks electronic equipment. Right. So we can't tolerate variable power. So wind is really, really variable, like and those variations happen all the time. Um, but like on a constant basis. But you can have these lulls that last for days, and then you can have these spikes where they're really, really windy and the turbines have to shut down. They can go for days, but you can get like a run of those days over weeks. And it's not and in the data, this actually this is a problem that needs to be looked at. Solar, you've got variations of you've got the day-night variation, but you also get like cloudy weather and where the sun doesn't shine as well for periods of time. But then you've got a long-term variation. Did you know, for example, the sun in winter is not as strong as the sun in summer, right? And so you think, well, okay, that's a very basic thing to say. But but what it does means is solar does underperform for several months of the year. And in fact, the US Department of Energy picked up my work and did an internal audit, and they found for 2 years in a row, wind and solar did indeed underperform for about 6 months of the year for one reason or another. Right? And they needed support, and that support generally comes from another power source, usually gas. Gas is very flexible; it's cheap. You can turn it on or off at will, and all that. Take away the gas industry, we don't have our buffer anymore. So conventional thinking believes the amount of buffer that we need is 5 to 7 hours. There's a Princeton University put out a study called Net Zero America. It's a very nice study, very well done. They looked at short-term variations between supply and demand. Sometimes one outstrips the other, and so you need to keep, like, say, maybe 6 or 7 hours of power, and you keep it for, say, 4 or 5 days, and that's all you never need. They did not look at long-term variation. So what I'm saying is, it's not that the work of others is wrong, it's that it never occurred to them to look at a particular issue. And so it's a blind spot in power management. It turns out we don't have the technology to store such a lot of power for an extended period of time. We're talking about storing power for, I do 4 calculations. There are 6 hours, 48 hours, 28 days, and 12 weeks or 84 days. And those last two sound scary, but that's actually closer to what we need if we are to replace the gas industry. Right. And so I get a lot of criticism, and a lot of people sort of go, that's not true, it's not possible. But a lot of the studies that are actually out there, they tend to be market studies that look at market price. They don't look at, for example, material flows on the ground, or they won't look at storage. Like they'll look at wind turbines and solar panels only, not the buffer storage that sits behind them. And so I'm getting shot at from all sorts of directions. I've had two people contact my employer to actually sort of have me removed from my post. It's all very asinine. But the work has actually been put out there. It's the initial work, 1,000-page report was peer reviewed by 25 people. That they went over it, and since then it has evolved quite a bit. 2 years ago, I put some papers into a journal to be published. Here we are 2 years later, and we're in the final stages of getting through that. Round 3's been handed in and corrected. I don't know. Is that the end? I don't know. I keep thinking I'm done. But what was interesting, at the time, I was told I'm not allowed to so much as write a blog about some of my stuff, right? Because the anti-plagiarism software would pick that up and accuse me of plagiarizing myself and cancel my own paper. So meanwhile, on social media, I'm sort of getting shot at from all sorts of directions here. And yeah, have him fired, get rid of him, he's wrong. And the people who oppose me can operate with absolutely no ethical boundaries at all. And it's all very schoolyard-like. And I'm actually sort of put in this very odd situation where I'm not allowed to so much as write anything at all in an opinion piece at all, or publish another paper at all until this larger thing is finally sort of coming through. And once it's published, it's peer reviewed, that's it, that problem goes away.
Mm.
But it's this very sort of strange like guys, you've got a problem here. You've got a very serious problem here, and so far, no one's been able to actually prove me wrong. For example, the sun in winter is in fact not very strong compared to the sun in summer, and there is a difference in performance. Can you refute that? Silence. Yeah, and so a lot of the attacks do tend to get quite personal. It's quite a it's been a very interesting thing where I've actually learned a lot about people, not just like the industry side of things, but people. Oh, Robert, I think you've frozen. Are you still there?
Yeah, let me come
Yeah.
back.
Yep.
There we go.
Yep. Yep. Okay, we're good. So yeah, it's how do human beings deal with change,
Mm,
and can they observe something unusual?
mm.
Yeah.
Can you walk the audience through your new vision of a circle economy? Because it's not just saying, "Oh, everything that you guys are doing is not going to work," and
Oh
I'm
no no no
done.
no 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 no
And
no
yeah,
no no no
so
no.
yeah,
We're human beings. We love our magic bullets, and we love our single solutions, but we also love our single criticisms. You're
yeah,
entirely wrong, or you're entirely right.
yep.
Okay, so it's like I've pulled everything apart down to its basic components, and I've built something new. The existing circular economy is thermodynamically imbalanced, but it's the best game in town. That's where we're going. Right. So the idea is you would collect all inputs, for example, the stuff that we consume, all the things that society buys. When we
Mhm.
throw them away, instead of like dumping them in landfill, which is what happens a lot of the time now still, is we collect it and we recycle it. And then we take that recycled products and then we feed it straight back into the manufacturing sector. And the idea is the amount of stuff being mined reduces. The original idea was there's no mining and there's no landfill. It's a perfect circle. Unfortunately, that's not how we're actually operating in technology development or consumption or waste handling. I put forward the idea of the resource balanced economy, where we would look at something and look at all material flows, put an energy term to each one of them, do things like start to design things where they can be recycled, restructure society where we can actually collect things effectively and get the right residue to the right process plant, and then simplify our design, our equipment, so on less components, for example, that can then society can run on less components that are simplified, that we can make ourselves easily from materials that we can indeed recycle from our waste. That simple step doesn't exist at the moment. So first of all, we've got to see raw materials differently. They're much more valuable. We've got to understand that every industrial action has an energy component. We've got to treat energy and raw materials as they're truly valuable. The commodities industry has been misunderstood, I believe. It's seen as just as a market action, just throw money at it and we get what we need and that's the end of it. We've got a series of finite natural resources that have engineering restrictions and extraction. And where you've got raw materials, you've got the technology to extract those raw materials, energy, the technology to use that energy, economics, right? Yeah, and so you've got those 4 points, and they're actually when you see one, you see the other three, and you cannot split them apart. So then design a society around the idea where they're not split apart. Okay, so then there is the question is, right, where do we get our energy from? Wind and solar, for example, were flagged to be the primary energy system after after fossil fuels. I believe both of those systems have their place, and we will expand them from what they are now, and we will use them, but they won't be the primary energy system. What I call the purple transition is based on three technologies that sit in the center of everything that around that um, around that they become the facilitating technologies, a gateway technology that facilitates everything else. And everything else that we've got on the books at the moment, and I mean everything, will continue to be used through those node points. The three technologies are, okay, you've got two sides of the equation here. You've got generation of electricity and heat. On the other side, you've got application. The application, we've got transport, generation of electricity, and we've got manufacture. So there are our macro scale tasks. Fossil fuels are going. We take them out of the equation. The systems that we were going to put in do work, but they each have scale-up issues. Every single energy system I assessed and looked at works, but it has a scale-up issue, a logistical issue, not a science and technology issue, a logistics issue. One of those sectors has to evolve if they're to help us. And what I found is actually something very old, 50 years ago, an evolution of the nuclear industry. Right, so the existing nuclear industry is too complex, and I don't think we're mature enough as a species to handle it as it is at the moment. The waste plume that comes off this that needs such storage for a long time, and it's very complicated. And we also don't have the people with the right education to actually sort of handle all this stuff to expand nuclear very much. What I found was a report from the Oak Ridge Nuclear Laboratory in 1972 on liquid fuel fission using thorium as the fuel, but you can also use uranium or you can use spent nuclear fuel. So you have like a mix. So what I'm talking about here is thorium molten salt. Now, this was an idea. This was a report that I found and went through it. I found a few things. The decision at the time was this is back in the 70s. We didn't have an energy crisis. We didn't have an environmental crisis. We didn't have raw materials crisis, but we did have the Cold War. And the military, the American military in particular, were calling the shots. And they said that we want a civilian uranium nuclear circuit to operate, which will camouflage the production of nuclear weapons. If you go thorium, that will not be the case. Also, thorium was a lot simpler, and we couldn't make as much money. And so the idea was to sort of kill the idea of thorium. Here we are, a couple of decades later, 50 years later, and it's back. Right. So there is a commercial company in Copenhagen. It's called Copenhagen Atomic. They are actually in the process of manufacturing small modular reactors, and they'll be ready for sale in 2028. What the difference is, the reason why I'm talking about this is when you put together a nuclear power plant that's based on your conventional uranium, you're only using 3 or 4% of the fuel because of the isotopes involved. U-235 is the isotope we want. That is naturally in uranium about 0.7% of pure uranium, whereas U-238 is most of it. So the enrichment process is to increase the amount of U-235 to about 4% of the fuel. Put it in the reactor, it does its thing. There comes a point when it can't sustain the reaction anymore. You've got to take it out. When you take it out, it's 96% still uranium and it's very radioactive and hot. Thus the problem. Thorium, though, thorium salt is made, and it's much simpler. The mining footprint's much smaller. It's several orders of magnitude smaller than the uranium system. We only need a small amount of material to do the same thing because a much larger proportion of the thorium fuel is usable. You end up using between 99 and 96% of the fuel. So we've gone from 3 or 4% to 96%. So you don't have the waste coming out. Thorium on its own is not, it's what's called fertile. It's not a radioactive. It's in itself. It's got to be converted to uranium in the reactor. Right. Long story short, the stuff that comes out of these thorium reactors is much less in size in terms of waste, and it's not as nasty for the isotopes involved. And it's the equivalent of running a medical isotope lab in a hospital. They're the kind of isotopes you tend to get. So this group in Copenhagen Atomics, they are making a 100 megawatt reactor for heat or 40 megawatts of electricity that would sit in a 40-foot shipping container. And 50 years of fuel is loaded into this thing at installation, and you've got a 5-year cycle of maintenance. Right. So the problems associated with building a normal nuclear reactor that takes, 20, 30 years or whatever, and there's this massive concrete structure and everything, it's an entirely different proposition, and its safety footprint is very different to conventional nuclear. What I'm getting at is this is a way of generating electrical power, doesn't use fossil fuels, doesn't need the massive resource requirements of wind and solar. It's a concentrated source of energy and can be put in any weather, in any location around the world. And because it's small, it's actually much easier to manage from a security point of view. It's also military uninteresting. Like there's no point in actually using thorium to make weapons with, even in spite of the current belief that that is the case. Anyway, so that is one of the three technologies I've looked at. We can generate electrical power. The second one was ammonia-fueled ICE. I believe electric vehicles and hydrogen fuel cells will be in the system, but they, like everything else, face their scale-up issues. Ammonia ICE is something that the Maersk have now started putting out for large ships. The problem with ammonia is a very toxic substance, very corrosive. Under compression, it liquefies, low compression, but when it gets hit atmosphere, it turns into a gas. That gas is poisonous to living things. What could possibly go wrong? So when you burn ammonia, you've got nitrous oxide, laughing gas, which that needs to be managed. You've also got the problem of unburned ammonia coming out the exhaust as well. So there's a number of technical engineering problems. Toyota have released a press release stating that they're working on, or they're ready to commercialize, a passenger car ICE ammonia vehicle. If that is the case, if Toyota really has actually resolved these, when a large corporation says we've done something to make money, have they really? Yeah. So we'll have to sort of wait and see. But if that works, right, then ammonia fueled ICE could then move into parts, not all parts of our system to actually operate. If the safety concerns are not met, then we scrap the ammonia ICE for passenger cars and we just use them to run ships. And a portion of the shipping fleet to actually sort of move things around would use that. We obviously won't need the whole shipping fleet. The third technology is associated with heat. When we manufacture stuff, we need large quantities of heat. Like, for example, when we manufacture a solar panel, one of the conventional ways to do it, there are others, but you take quartz, silicon quartz, and you heat it to 2,200 degrees Celsius to make a silicon wafer. That makes our solar panels. At the moment, it's done, almost exclusively by the Chinese, and they use coking coal to do it. Coking coal. So a lot of the solar panels that are out there were made using coal. There's a direct link between solar and coal. Take the coal away, and we've got to generate the heat some other way. How do we do that? Now, traditionally, we sort of use hydrogen, but the problem with hydrogen is you now need to generate that hydrogen. And if you are going to generate with that gas, like we do at the moment, then you've got to use electrolysis. And so you now need lots of electricity. And the amount of electricity is huge because the amount of coal has been huge. All right. So we need the other one is some forms of biofuels could take us there, but the amount of biomass that the planet would have to supply far exceeds what it's actually capable of doing. So that's not sensible either. And you can use an electric arc furnace in some applications, but not all. Right. So now we're back to more power. There's a group again in Copenhagen called Metalot that has actually proposed a very interesting, um, very interesting solution where they burn metal powder, iron powder. So they take iron powder and they burn it. It takes a lot to get it going, but once they've got it going, it's got a thermal burn temperature of about 2,200 degrees Celsius. Now, most smelters run at 1,200 or around there. So we've got plenty of heat. We've also got plenty of iron. Here's the interesting part. When you burn the iron, it goes to iron oxide, rust, right? But you don't have to throw it away. You can process that rust back into fuel. You get it to interact with supercritical steam, or you get it to interact with hydrogen. and the oxygen is stripped away, leaving iron powder. Okay, hold the phone. So all that rusting machinery that's around us could be seen as a fuel source. Oh, wow. Wow. But also when we're building when you've got a power generator, you've got, for example, supercritical steam turning a generator. When you finish with that steam, you could use it to turn rust into iron powder. So that's saying there are lots of synergies there you could use. The numbers haven't been thought through on this, but those three technologies have less barriers in front of them than other technologies like solar at the moment. And what I'm talking about is not solar panels work, obviously. Um, can we scale them up to be, say, 10,000 times the capacity they are at the moment? If we electrify everything, we've got to think about how much the power grid must expand and where we get that power from. Those are the numbers that haven't been thought through. Those three technologies, so you've got liquid molten salt thorium generating electricity. You've got ammonia ICE, assuming they can get past some of their engineering hurdles, right? And you've got burning of metal iron powder. Those three technologies have the capacity to refit our existing industrial infrastructure in ways that doesn't require such a vast amount of raw materials, right? And they can then facilitate all other activities and will then allow us to actually look at some of the planetary scale environmental impact stuff that we've got to look at now that we can actually shrink our raw materials footprint. The whole commodities industry can now shrink, is the implication there. When I'm doing my the job in Hawaii, I'm like looking at phasing out the existing system and bringing in the new system. In all scenarios, trucks are taking up about 80% of the energy to get a phase out fossil fuels solution. And there's a whole lot of solutions. About 80%, between 78 and 86. Whatever, it's a lot. That suggests to me that society needs to redesign and reorganize itself where it does the same things that trucks do for us now, like a book called When Trucks Stop Running by Alice Friedman is actually a very good book that examines the issues of, our dependency on truck transport. So it's not just a case of just drive trucks less. Well, okay, society stops. It's like saying don't use coal in manufacture. Manufacture stops. So instead of saying stop it, engineer a new solution. And so the things I'm actually working on with the Venus project, if we were to redesign our cities where we could still transport goods around that city and between the cities, using rail, for example, would that help? And so when you actually look at trucking routes, there's a lot of them, but they tend to be non-linear. That is, a disproportionate amount of trucks are operating on the same routes back and forth. Well, a lot of them, for example, between major cities, between major depots and major cities. Right. So if you had a rail system to actually transport, and we had like a more extensive shipping container system that was actually designed and optimized for this purpose, and when you get to a city to move those things around, what I saw on a mine site once was when they actually are transporting ore from over rough terrain, instead of having a road and a rail, they had a series of pylons, and under those pylons, they had a conveyor belt underslung pods. You'd get something like a shipping container, fill it full of ore, and it would then sit on these wheels and it would run along a track, and then it would be lowered at the other end onto whatever's carrying it. So you have the idea of a monorail on top to move people and a circuit on the bottom to move shipping containers back and forth around a pre-arranged circuit. Now that won't replace trucks completely, but we can knock out something like 80% of trucks. So we still have some trucks on the road because we need the flexibility. There's just less of them. And the power that comes from that can come directly off the grid, which brings us up against the power generation systems. You don't need to make hydrogen and store it and all the stuff with that. So what I'm just saying is I'm sitting on a fairly large number of ideas that are unorthodox, and sensible people don't like them. But I've yet to actually see why a lot of these ideas won't work in the right conditions. So what I'm proposing here is fossil fuels are going. We looked at the green transition and the circular economy. Nice try, nice attempt, but we should evolve past it into something else.
Mm.
What that something else should be is where, to me, the game is.
I think one of the great challenges is that there's 4.5 to 5 times more wealth than there is GDP,
Yep.
according to the last Credit Suisse report. There are lots of cash sloshing around. Every single one of the climate tech, climate investment funds are not impacting climate at all. They're creating unicorns. So they're giving their 10x returns to their investors. If you see the tens and maybe hundreds of billions pouring into EVs and batteries,
Yep.
and I looked at, well, how often is a car parked?
Mm.
It's like 20 to 24 hours a day
Yeah.
on average. And they travel 40 kilometers a day worldwide average. And the US, half the cars travel only five
Mm.
to 8 miles a day. So
Yeah.
all of this money is pouring in there for the unicorn chasing, but not addressing climate when public transport system or public transport on demand would be a much wiser use of resources.
So I live in Finland, in Helsinki at the
Mm.
moment, and we've got this metro system here, which is great.
Yeah, yeah,
Public transport here is amazing
it
to the
is.
point where I don't need a car, but you got to build the infrastructure to do it.
Yeah.
So when we're looking at the circular economy, and like studying the existing system, we've created a system around us that is amazingly complex, the most complex thing the world has ever seen thus far. And we've done it with the support of this energy we call oil, which is a really sort of calorically dense energy system. Remove that oil, what do we do? Right. So we've evolved into what we are now because it was the natural, it was human innovation took us in this direction. Why do we develop an internal combustion engine car? Like, so why did we not go with the bus, for example, or the
Yeah.
truck? And the answer was at the time, things moved around. This is like back in 1900, 1880, things were being moved around in horse and cart. If you want to move something, you move it in this four-wheel thing called a cart, and you put a horse in front of it. An ICE engine vehicle is a horse and cart without the horse. So society could understand that, and they evolved into it. What we are moving into now is an era where we've got to reimagine transport. But instead of actually sort of ripping out one system and putting in another system that's identical, like an electric vehicle, for example, is the same basic idea. Four wheels vehicle, we all want one, and it's convenient. Isn't life grand? Um, so now the kind of innovations that have actually coming forward, where society is comprehensively reimagined, where we do the same things, but we've got to be a bit more responsible about how we do things. Excuse me, just want to shut this down.
No, that's problem. That's
Yep. So yep. Sorry, someone's trying to call me. So
that's okay.
no,
How
no. So
can how can we help you? Because a lot of the work you're putting in public domain, but how can we help you?
that's an interesting question. So there are two basic problems here the society faces. One is we are spending our time discussing the wrong things. Right, like we've got the wrong end of the stick. The vast amount of society does not understand the nature of the challenge in front of us. So get out there and discuss it, and the average person's got to understand what we're facing. The second problem that we are having is we've got to take all these ideas and do something with them. There are lots of ideas. There are lots of things we could do. What we need to do is take those ideas and turn them into an engineering reality to see if they work. And if they do work, then market forces step in and then we're away and we're off on the next technological stage. But we're in a bottle. we're in the place at the moment where we can't actually get ideas off the ground because we've got all these ideological tribal barriers
Mm,
stopping it from happening. And so what I wish to do my next industrial area is to leave my current post and go and build an innovation hub outside the Western world that will look at unorthodox ideas, take those ideas and turn them into pilot scale engineering outcomes. The vehicle that I'm looking at doing this is the Venus Project. Now, there are
yeah.
others. What I would ask people to do is to support the Venus Project. Give them donations, get them going. We're about to launch properly into something a bit more substantial and actually sort of in a planned fashion. But that will actually provide a paradigm shift that will provide an example we can all look at outside the existing system, and then people can then say, well, that works, why don't we give it a go? So either could you support the Venus Project, or two, get out there and create an equivalent yourself. As in, start the ideas where we can look at start the thing where we can look at unorthodox ideas and turn them into a physical reality that we can all see. That's the bottleneck at the moment.
But which country are you going to
Uh,
do this pilot?
So, interesting question. So, I'm actually we're talking to a group that owns land in Peru, in South
Mm,
America. I don't know if that'll go ahead or not.
mm,
But when we actually launch, we need someone, preferably private land, but that has a good relations with the local government outside the Western world, because we have this way in the Western world to shut down any unorthodox ideas. Whereas if we set it up like a mine site in the middle of nowhere,
mm.
right, like if I could take it to Australia, for example, and go out into the middle of the desert and set up shop in a piece of land that no one else wants, that would be ideal. I'm looking at Peru at the moment, but we've yet to actually sort of get agreement. There's a few hiccups along the way. That may not happen. There's another site in Hawaii. There's another site in Japan. There's a couple in Africa. And so I tried to get it going here in Finland, and they laughed at me. They said,
Yeah,
"Oh, no, 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 we've got everything in hand now. We don't need your ideas. Go away."
you might want to try. I have to look up her name. I'm having a senior moment. The woman who was the founder of Esprit, who bought all this land with her husband in Chile.
Okay.
Chile, and very focused on sustainability and ecology, and also Yvon Chouinard's foundation from Patagonia. So
Yes.
I'll look up the name
Yeah.
of the two organizations and send that to you. I'll also put a link to your 1,000-page report for people who love that kind of light reading,
There's
kind
a
of romantic comedies.
there's my website as well that I try and put.
Yeah.
I haven't updated it for a while, but
That's
it
okay.
all
I'll
all.
share that
Do you have
with
my website?
yeah.
Yeah.
I'll
Okay.
share
Yeah.
that with everyone who, because a lot of people watch the replay and they
Yep.
don't particularly come
Yep.
live. So
Yep.
we'll share that
Okay.
with everyone. And if there's anything specifically that we can do to help you, I found it really weird that all these people were for the first time coming at me and what are you doing? It's horrible choice that you have this guy. But everybody had this financial interest that felt threatened by what you were saying.
Yeah. I have to remember I've offended a multi-trillion-dollar industry. Um,
It's
and
okay.
I do apologize to the people who've had their careers impacted to these ideas, but I'm trying to look at the facts.
Yeah.
Right. And I'm not anti-climate change. I'm not pro-fossil fuels, but I am actually trying to find the genuine way forward where my work is actually meaningful. So
Did you try Prime and Breakthrough Energy? Do you know those two?
so yes, I do know this, Sue.
Okay.
The pitch is still being refined, and the
Okay.
plan is still being refined, and we're still sort of getting the um how it's all going together. But it will come out of the Venus project in Florida.
Okay.
And when we're ready to launch, we'll shout it from the rooftops, and with luck, you'll see me do it.
Yeah, I mean, believe it or not, I'm probably the only person who on this podcasts that actually worked on oil rigs. And
Okay,
so
well, there
I
you
worked in the North Sea, in
go.
Texas, in France, in Iran. So I know what it is to make a hole in the ground. I was always surprised that there were not more accidents because I never met so many incompetent people who were in positions of power. But opening up the valve, it's very easy to get your bonus. So what you're talking about is threatening to them.
Yeah,
And I love when they say, "Oh, we have to spend so much money for infrastructure." And I'm trying to think back, in the 1800s, there weren't that many gas stations around either.
yeah, yeah. I do think there are a number of things that we work on that have we've got the wrong paradigm. We should be looking at restoring life systems on the planet. We
Yeah,
should start with the seas. There's more plastic in the seas than fish now.
yeah.
Now, I've proposed a number of solutions for that, but what I like to say, there's been way too much talky and not enough wickety whack.
Yeah, yeah, yeah. Well, it's,
And
the ones that do the most talk the least, and the ones that do the least talk the most. You might want to also reach out to a woman named Patricia Ricard. So,
okay.
Ricard Pernod,
Hmm.
that drinks. So she's the granddaughter. She's not involved really in the company or investment, but she has a very big oceanography research institute
Ah,
close to
yes, that's the
France.
one.
Yeah, yeah. Patricia Ricard, very nice woman. We did a master class there, and she would probably be interested in anything related to ocean cleanup, ocean industry, and
Yeah,
restoring the
yeah.
health of life system there. No,
I'm
good soul, very good soul.
I'm going to put on the chat here. Let me
Hmm.
see if I can find it.
Okay.
My plan. Some um, oh,
And everyone who registered will have access to the chat and the replay, and we'll send a link to your website and
so
also the report. We're going to do a virtual mixer. You're more than welcome to come, but if you're busy, I understand. So
everyone's after
anybody
me.
who's here, there's a link I put in there. You just click on that link and it'll take you to the virtual mixer that we do. And the
So
system connects you for a 5-minute video chat with someone new.
to actually show that it's going into the chat.
Okay.
Okay, there it is. Just to show that I'm solutions oriented and deadly serious about this. Mining plastics out of the ocean and converting it to diesel fuel with pyrolysis.
Okay. Yeah.
The reason you do that is when you do that, the volume of the plastic shrinks down to much smaller. And so when you've got a ship full of plastic, what do you do with it?
Okay. Yeah.
Right. And so then if you convert it into is actually still useful, take the fuel away and use it. And with AI and automation, you could have this ship go up and down the plastic gyre of the Pacific Ocean like a lawnmower and keep going. You know, and
Did you type it in the chat area? I didn't
it's
see
in.
something.
Oh, hang on. It's to
I think
let
you
me
got to
say it to
press
everyone.
return or something.
Everyone. No. I
Okay,
sent it
there
to
we go.
someone
Oh,
directly.
there
There
we
you go.
go.
There we
Okay,
go.
excellent, excellent.
Anyway, so that's
Simon, it's been a joy. Thank you so much. And keep up shouting that barbaric yawp over the rooftops of the world. You have a fan in Amsterdam. So, I mean, I'll tell you, we were once bombarded by the MAGA Republicans before they were MAGA Republicans, doing the same thing, targeting us because we invited a particular speaker that they didn't like, and they did everything. So these guys are punks. And I invited them. Why don't you just come to the session with Simon and pose your questions?
they
All
never
of them
oppo
refused.
they never oppose me directly.
No, no, they're
They
cowards.
they they never ever actually oppose me. I think there's only one guy that's actually debated me directly. Two. One guy called Uka Ho Extra, and
Oh
another guy
yeah.
called
Okay.
Nafis Ahmed. The rest
Yeah.
of them
Yeah.
want to flame me on Twitter, but won't come anywhere near me. When
Yeah.
I present in person, it's 100% positive.
Yeah. Thank you so much, Simon. You're a star. And we're gonna if you want to join the virtual mixer, just click on that link I posted in the chat,
Okay.
and the system will take you there, and you'll be connected for a 5-minute video chat with all kinds of fans.
I will. I've got a call to make, but I will after that call. I'll join.
No worries. Thank you, Simon, so much. You're a
You're
star.
welcome. Thank
Stay
you.
well. See you all soon. Bye bye.
Okay.